Okay, exterior angles of triangles. So the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. As an equation, we look at this as the exterior angle is equal to the sum of the interior angles. So let's take a look at this diagram because this is a lot to break down. So I've got two interior angles. I have an exterior angle that I created by extending one of the sides of that triangle. So I'm extending this here to create an exterior angle. And this is equal to the sum of the two non-adjacent. So it's equal to these two angles that are on the inside but are not touching it. So I like to actually mark up my triangle when I do this. See my exterior angle here, and I put an equal sign. Oh, my marker's dead. I put an equal sign just inside, and that is equal to the sum of these two. So I'm going to add up these two angles, and that's going to be equal to the sum of this exterior angle over here. My equation, again, I like to think about the interior is equal to the exterior, and that works for a triangle. So let's try a couple of these, see how these go. All right, so what have I got here? So for my first one, we're going to find the value of x. So I've got a diagram here. Here's my exterior angle that I'm missing. And I've got two non-adjacent interior angles. So notice that those two angles over there are not touching my exterior angle. So I'm going to set up my equation doing the sum of the interior is equal to the exterior. So I'm going to take my 28 plus 64, add them together, and that is equal to my exterior angle, which in this case we're just calling x. So this is a pretty straightforward equation, nothing really fancy here. I'm just going to add the two together on the left-hand side there, and I get 92 is equal to x. Now if I fill in the rest of these, like I could easily use my interior sum of triangles to come up with this missing one here. That should tell me that that 92 for my exterior makes sense also. All right, one more. This one has a little more of an algebra feel to it. So again, we're going to find the value of, it should be the value of a, not the value of x. I hope you caught that. So I have 3a as my exterior angle here of my triangle. Again, I'm noticing this only works for a triangle. Here's my interior angle that's adjacent to that 3a. So I want the other two that are not touching my 3a angle. So my equation is going to look like my interior is equal to my exterior. So I'm going to add those two interior angles to equal the exterior. So a plus 7 plus 87. Notice this a plus 7 is in parentheses. Again, that's just to point out that it's not 7 degrees. It's a plus 7 degrees. So that's the only reason my parentheses are here. Once I get going, I can pretty much ignore them. So I've got a plus 7 plus 87. Those are my two interior angles, and that's equal to my exterior angle, which in this case is 3a. So I'm going to combine like terms here. Remember, my middle of my equation is my equal sign. Combine like terms. I have a plus 94 equals 3a. I have addition on the left-hand side, so I want to get rid of that. I'm going to move the a over by subtracting it from both sides. I end up with 94 equals 2a. And my last step here is divide by 2. So I have 47 is equal to a. They only wanted to know the value of a, not x. They only wanted to know the value of a. But if they asked me the measure of the angle, then I would go back and say, well, what is 3 times that a? So in this case, since a was 47, 3 times a, well, let's be 3 times 40 would be 120. 3 times 7 would be 21, so 141 would be the measure of my exterior angle. So again, triangles, the two non-adjacent interior angles, their sum is equal to the exterior angle.